Hey, welcome back. In this video, we're going to talk generally about experimental design. In our work towards becoming very powerful statisticians, what we need to learn how to do is how to investigate the relationship between explanatory variables and response variables. Again, generally in the work of doing statistics, what we're looking to do is to investigate how things are affecting other things. An explanatory variable is a variable that causes change in something else, and a response variable is simply something that changes as a reaction of an explanatory variable. In other areas of mathematics, we often will call the explanatory variable the independent variable and the response variable the dependent variable. And again, the relationship that we're looking at investigating is how changing the independent or explanatory variable affects the response variable. In doing our research, there's generally two different ways in which we're going to investigate this relationship. We'll often be doing observational studies. These are studies where we're observing or collecting data without manipulating anything that involves the relationship between these two variables. Very different than that would be an experiment. In an experiment, we're actually actively changing the states or conditions of the explanatory variable and to see how it affects the response variable. An important part of this is the word treatments. The word treatment is the different types of states or conditions that we give to the explanatory variable, and then we study, observe, and collect data about how the response variable is affected by those changes or different treatments. And as we've done so far in this class, is we're taking a very wide view of how we go about and do this research. But I want to emphasize something we've talked about before, is that what we need to do is to try to investigate is the relationship between the explanatory variable, the independent variable, and the response variable, which is dependent on the explanatory variable, or we assume is dependent. We want to see if that relationship is correlational or causation. This is sometimes very difficult to investigate, but just to clarify again, what we're saying is if we see some kind of relationship between these two variables, are they correlated so that they just happen to happen with the same kind of frequency or some other measurement that we're using? Or is there a direct causation? Is the explanatory variable actually acting in some way on the response variable? If we are able to prove that explanatory variable has a causative effect on a response variable, we have something very strong that comes out of that experiment. But I want to emphasize it is very hard to get to that point, especially with an observational study. As we go throughout this class, we'll talk more about how we can do this kind of investigation. But for instance, there's many relationships that might have very tight correlations, but have no causal relationship at all. For instance, if we were to look at, for a given city, the consumption of ice cream and the incidence of drowning in that city, we might say, hey, look at the data. As more ice cream is consumed, there's more drowning incidents. When maybe it's obvious those things aren't directly related. It just so happens that in the summer, both ice cream consumption goes up and the amount of folks that are swimming goes up. As we move forward in statistics, we'll talk more about methods, mathematical methods for investigating these relationships and determining correlation versus causation. Within an observational study or an experiment, there are different methods that we will use to investigate causation versus correlation. Also, something that muddies the waters between this relationship, not only the conversation of correlation versus causation, are third-party variables that murky the data that we get from either an observational study or an experiment. These are called confounding or lurking variables. Confounding and lurking variables can appear in either an observational study or an experiment. What a confounding and lurking variables do is they affect this connection or this relationship between explanatory variable and a response variable. You don't need to know all the details between these two, but I will just state that a confounding variable is generally a variable that is known to researchers and will be described in the write-up of the evaluation of the research, but also things will be done within the experiment or the study in order to try to deal with the confounding variables that muddy the waters in the relationship between these two variables. Lurking variables are exactly the same. The only difference between lurking and confounding variables are lurking variables are variables that are unknown to the researchers. And important at this point is just that you know that in any study or experiment that you do, there will almost always be confounding or lurking variables. Your job is to do certain methods of research, sampling, and experiment design so that you can minimize the effect of these types of variables. One way of dealing with confounding or lurking variables in some experimental designs is to have a control group. A control group is a group that you are studying that is given a placebo. So they're not given the active treatment of the explanatory variable. If we're in the instance of a new medicine coming to market, they're given a sugar pill. They don't know it's a sugar pill, but they're given a sugar pill, and that is compared to a group that is given the actual treatment of the new medicine. Then the results of those two groups are compared, and it seems crazy, but the important thing to understand is that one of these confounding variables is that if you think you are given a medicine that will help you, that actually can have some real change in your health or the reaction to the treatment, or in other words, the perceived treatment. Additionally to this idea of placebo and a control group is the idea of blinding. So what often will happen is that you have the control group and the treatment group. Neither will know which group they are in. They won't know if they're given a sugar pill or this new medicine. So in that case, what we're doing is blinding those participants. They don't know which one they're given. If that's not enough to deal with these confounding or lurking variables, we can do double blinding. Double blinding experiments mean that the participants in the experiment or the study don't know that they're involved or whether or not they're involved in testing this new medicine, for instance, neither do the researchers, the ones administering the new drug. There is so much we could actually talk about generally with experimental design, and we're going to talk a lot more about this as we move forward throughout statistics. The goal of this video is just to introduce these concepts, to just walk through this again. We have explanatory variables and response variables. Response variables react to explanatory variables, and we're investigating that relationship. Importantly, though, we're investigating whether it's correlational or causational. Is there causation? Is the independent explanatory variable actually directly affecting the response variable? And there's different things that we can do. But within that, we're muddying the waters with these confounding or lurking variables, what may have significant influence in that correlation or causation relationship. Finally, the two general ways that we'll go about doing our research is whether we have an observational study, which is observing things that are happening, collecting data without manipulating anything. An experiment is in the case we're going to be given different treatments to the explanatory variable to see how it affects the response variable in investigating this relationship.